Hello, welcome students. This is the topic magnetism, and this is maybe second last content of we are discussions in the same topic, that is magnetism. This is one of the laws we are just discuss in the topic, that is electrostatic. In these lectures or in these topics we are discuss the comparisons of the topic of electrostatic and magnetism. In these lectures we are discuss the famous law, Gauss Law of magnetism or Gauss law in magnetism. In the Gauss law, we are the same law we are discussed in the topic, that is electrostatics. The Gauss law, net electric flux, that is psi E, is equal to electric field E dot ds. Ds, it is the surface, is equal to net charge is equal to or proportional to the net electric charge. This is the Gauss law we are study in the electrostatic topics. The Gauss law of electrostatic topics, the net electric flux, is proportional to net electric charges. Net electric charges. We are studying the net electric charges. This is all about the Gauss law in the electrostatics. When there are some difference, there are Gaussian surface, closed surface, anything we are just consider, that is surface ds is a closed surface वगैरह वगैरह आपण काहीतरी म्हणलेलं होतं. In the Gauss law in the magnetism, the Gauss law in magnetism is state that the net magnetic flux, not electric flux, the net magnetic flux phi b is through a closed Gaussian surface is 0. In magnetism, the Gauss law state that I will use a different colors. The Gauss law state that the net magnetic flux through a Gaussian surface is equal to 0. Then I will be write the same equations as like this. The net magnetic flux is equal to integrations of the magnetic flux with the Gaussian surface ds is equal to 0. This is the Gauss law in a magnetism. That's now they are finished, not finished the lectures. We are just discuss some magnets. Where are the magnetic field will be produced, where are the electric field will be produced. I will be drawn some diagrams. Then we are just compare the magnetic lines of forces, electric lines of forces, or some surfaces, that is Gaussian surfaces. I will be drawn 3 different diagrams here. In the first part of the portion, I will be use bar magnet. In the second portions, this will solenoids. So when current will be flowing from the solenoids, they also produce the magnetic field. When we are using the right hand thumb rules, then this is the conductors, that is current flowing through these directions, and they surround it, the magnetic field will be produced. Then this is solenoid is also taken the one of the part. Then last is electric charge. Electric charge. Then I will be drawn here a magnetic bar magnet. This is our bar magnet, that is north and south poles, and this is one of the solenoids. They are not exactly increasing the surfaces or increasing the area in between them, but some mistake I will be drawing here. Next one is charges. There will be two charges, that is positive, and there's negative charges. Then the magnetic lines of forces or electric lines of forces will be start here. This is the magnetic lines of forces. They are produced surrounding, and this is the surface or Gaussian surface here, the surface 1, and this is another surface 2. Consider two different surfaces, surface 1 and surface 2. In here, let's this is the solenoids, they are also produce the magnetic field. And I will be consider the two different surface. This is the Gaussian surface as same at the point, and ही जी Gaussian surface आपण या ठिकाणी घेतलेला आहे, हे नंबर ऑफ जे काही छोटे छोटे डॉट्स बाहेर येत असतात त्यासाठी आपण या ठिकाणी Gaussian surface घेतलेला आहे, random surface. And in here this is the second surface. In this is second surface at a top upon north poles, and in that sides this is a second surfaces. And electric charges, they are flowing, electric lines of forces flowing through the positive to the negative charge, like this. They are not coincide to each other or not intersect. And this is our Gaussian surface, surface 1, and this is the surface 2. These are the three different components, that is a bar magnet, solenoids, and electric charges. They are also produced some fields. They are electric field, magnetic field also. In a surface 1, this is surface 1 is at a bottom of three different diagrams. तिन्ही वेगवेगळ्या फिगर मध्ये बॉटम साइडला जे surface 1 आहे, surface 1 equal, the number of lines of forces are equal in a surface 1 when they are entering and leaving. हे जे आत जात असतात किंवा बाहेर येणार जे काही लाइन्स आहेत, it is not showing the numerically, but they are equal. In a surface 1, the lines of forces, in here electric lines of forces, and in these two figures there are magnetic lines of forces. The lines of forces are equal when entering and leaving. Entering and leaving. This is first and important terms, and these are all same, all diagram for a same of for first surface. सगळ्या diagram साठी first surface साठी हे same sentence आहे. आता आपण डिस्कशन करायचं आहे सेकंड सरफेस साठी. The Gaussian surface does not included poles. Gaussian surface does not included poles. The Gaussian surface, the Gaussian surface does not included poles. Gaussian surface are does not included poles, then it associated that the flux with any closed surface is zero. It associated that a flux of any closed surface, and its sentence is associated that flux of any closed surface, any closed surface is zero. हे फक्त एक्सप्लेनेशन्स पार्ट आहे. एकदा वाचलं की आपल्याला एक्झाममध्ये डायरेक्टली लिहिता येतं. दिस इज द मेन पर्पज, दिस इज द मेन गॉस लॉ इन अ मॅग्नेटिझम. द नेट मॅग्नेटिक फ्लक्स इन अ क्लोज्ड सरफेस थ्रू द गॉसियन सरफेस, the net magnetic flux through the Gaussian surface is always zero. It gives 2 marks. Let's start a comparison between the electric flux and magnetic flux. Gauss law of electric flux and magnetic flux. We drawn 3 different diagrams and give some explanations about that, and use 2 equations, that is one of for the electric flux, another one for the magnetic flux. They finish. It gives the nearby 4 to 5 marks. From second figure, okay, from the second figure, the surface 2 is enclosed by the poles. Like 2 is enclosed, this surface will be enclosed by the poles north south. Yeah, second surface it will be enclosed by the pole. Then from the figure 3, आता second surface साठी figure 3 मध्ये जायचं आहे. Filled lines begins from positive charge and ends to the negative charge. For a closed surface there is a net outward, okay, I will write for, okay, for a closed surface there is a net outward flux, hence it is does not include the positive charge, hence that does not include the net positive charge. Then the electric flux, according to the Gauss law, the electric flux is equal to, that is E bar ds, that is not electric, not net electric charges or not included net charges or positive charges. Then this is all about the Gauss laws. Q is a positive charge enclosed. Q is a positive charge will be enclosed. It is isolated electric charges is exist in an electric field, or isolated electric charges exist, but isolated magnetic charges does not exist. Isolated electric charges will be exist, but isolated magnetic charges does not exist. Okay, let's start to revise in. What is the main purpose to study of these lectures? This is, we are studying the Gauss law. What are the Gauss law? And just difference between the Gauss law, when they gives the electric flux, and the Gauss laws, they gives the magnetic flux. Gauss law is gives only flux. When we are consider the electric flux in the electric field, then we are use these equations. The net electric flux of a closed surface, of a closed Gaussian surface is equal to, is proportional to net charges, net electric charges. Then the Gaussian law for the magnetic field, the Gauss law state that in the magnetism, the net magnetic flux through a Gaussian surface is equal to 0. And this is, we are considering different surfaces, different Gaussian surfaces, and let describe of these equations. And the isolated electric charges is exist, but isolated magnetic charges does not exist. This is the main and important equations or important sentence for these lectures.